Well guys, we have done this problem in the worked examples with the logic. You can go back there and check it once and come back if you've forgotten it. Otherwise, the only simple condition to show that these 4 points are the vertices of parallelogram is simple. Let me name these guys. Okay, let's say that is the parallelogram we're talking about. And let's say this guy is the first point, that is minus 2, 1. I call this guy as A. I say this guy is B, that is 0, 3. That guy is C, that is like 2, 1. And that guy is like D, that is 0, minus 1. So what is enough condition to show that these are the vertices of parallelogram? Very simple. The slope of, I can say, AB should be equal to slope of DC. Right? Slopes of the opposite sides should be equal. That's it. Alright, the slope of CD or DC. That's one condition, and not one is enough, but I should also show that slope of AD should be equal to slope of BC. Now I have to show these two things. If that is happening, then yes, I can say these are the vertices of parallelogram, nothing much. So let's start with the first guy and try to check whether these slopes are same or not. So how do you find slope of AB? That is AB. So in this case, I'm talking about which points? I'm talking about negative 2, 1, and I'm talking about 0, 3. So that guy is like x1, y1. That guy is like x2, y2. And let's work it out. So slope is given as y2 minus y1 by x2 minus x1. So you get what? Y2 is 3 minus 1 divided by x2 is 0 minus 2. So that goes like 2 over 2, which is 1. So we got this guy. Slope of AB, we got it. So let's say M of AB is 1. So let me write here 1. Now is that equal to slope of DC? Let's check. So how do you find slope of DC? Go back again and check. Where is DC? This guy. So let me take slope of DC this time. For that I'm taking 0, minus 1, and I'm taking 2, 1. That's x1, y1, and that's x2, y2. Okay, so let's find the slope. M is simply given as y2 minus y1 by x2 minus x1. So that goes like, let's substitute here itself. Y2 is 1. 1 minus y1 is minus 1, so minus 1. Cool. Divided by x2 is 2 minus 0. So you get 2 over 2. Oh, that is 1 again. So I can see that slope of DC is also 1. So first condition is satisfied. Slope of AB and slope of DC are same. So it means they are parallel. Alright, cool. We understand this. But that's not enough condition. Why is that? Because there can be a situation like this where the opposite sides are parallel here, but these guys are not parallel. And that is not a parallelogram. Parallelogram should be like this, right? So this also have to be parallel to this, otherwise it becomes a trapezium, right? I'm not looking for a trapezium, I'm looking for a parallelogram. So it is very important I prove even these two sides are parallel. So how will I do that? Check the slope of AD, and that should be equal to the slope of BC, nothing much. So let's work on it. Slope of AD this time, when I'm taking A, which is nothing but negative 2, 1, and D is like 0, minus 1, and that's x1, y1 for me. That's x2, y2 for me. Cool. So what's the slope? M is given as y2 minus y1 by x2 minus x1. That's the formula. Who's y2 now? That is negative 1. Minus of y1 is 1 divided by your x2, which is 0 minus of minus 2. So that goes like minus 2 divided by 2, which is like negative 1. So we got this guy's slope is negative 1. Okay, so let's check the last one, the slope of BC, that is this guy. So for that I'm taking slope of BC is what I'm looking for. So my points are 0, 3 and 2, 1. Okay, so what's the slope formula? M is like y2 minus y1 by x2 minus x1. Okay, who's y2? That is 1 minus of 3 divided by this 2 minus 0. So it's negative 2 divided by 2, which is negative 1. Cool. So this is also negative 1. I can see that yes, the slopes of AB and DC are same. It means they are parallel. The slopes of AD and BC are same. It means they are parallel. It means ABCD is a parallelogram. That's it.